Alright, so longest increasing path in a matrix. This is a very straightforward problem. Uh, we are given a matrix with values, and we need to find the path which is longest increasing, which is the largest path that is possible, and it is strictly increasing. So 1, 2, 6, 9, this is a strictly increasing path. We can't get any other path which is larger than 4, and 9, 9 is not a path because it should be strictly increasing, right? So this can be solved easily using BFS. DFS, we can minimize it, and that will be well within the constraints. But there's another way to solve this problem, which we can call a bottom up DP. Right, making this up. Initially, the DP value is 0, 0, 0. Alright. Now, if we try to solve this mentally, where will we start? Well, we can start at the lowest value, isn't it? Or even better, if we start it at the largest value, either of the one, and we start from here. Why? Because there is no other element which is larger than this. Okay? So its value is going to be 1. Essentially, it's going to be 1 because there is no other value which is larger, and hence it can form a path with itself only, isn't it? So suppose I have a data structure. Right now it's a black box. It gives me the value and the index, whatever I need to access it. Right, and that value I'll use it to see if I have anything greater than this value. I'll see that there's nothing. Initial value will be 1, and there's nothing greater than this value, so I'll straight away erase this off and put a 1 here. Similarly, I'll do the same thing here. I'll put a 1 here. Next thing I'll get from that black box data structure, that will be 8. I'll see there's nothing larger than 8 either in all of the 4 directions. I'll straight away put 1 here again. Now I get 6. Suppose this 6 I get. I see this is not larger, this is larger. So either 1 plus 1, 1 plus 1, which is initial value of this in itself, and 8, this can form a path, right? So this will be 2, or I get this one, this can form a path, this will be 2 again, or yeah, that's it. There's no other value which is greater. Alright, so thank God. I get 2 here. Similarly, I'll see that I can form, with this, I can form one path like this and no other paths. So I'll form a 2 here. 1 in itself, and 9 also has a path of 1. So I'll add 1 plus 1, that will be 2. Mind that if there were another path which was giving me a bigger value, then I'll take that instead of this one. Alright. So now I get 4. This 9 and 8 which is greater, both will give me 1, so answer will be 2. Now I'll get 2. 6 is the only value which is greater in the 4 directions. That will give me 3. Now I'll get to 1. 6 will give me 3. 2 will give me 4, and 1 will give me nothing. So I'll take 4. I'll take the larger one. Finally 0. Finally in last one, only 8 will give me 1. So this will be 2. So finally my answer will be 4. Now the question comes, which data structure should I have? That black box, what should be it? It can be priority queue, right? And I can have 3 positional values or vector of int inside the priority queue, which will store the value as the first position and its index 0, 0. Similarly others. This will be a priority queue or max heap. Let's get into the code. This will be the priority queue. Sorry. I don't know what it said. Priority queue. This will be a vector of n since we are storing 3 values. We can take a triplet as well. This is cleaner. I'll traverse the matrix. First, I'll get the size since I'll be using that frequently. Dot size. This will be 0. This will be n. Here I will check for when the column in the inner loop instead of the size now have the variable. This will push the three values, that will be matrix of ij. This will store the values in order of the position first position's value, and I will have a answer variable which will initially have a min. Since I need the maximum, I'll initialize it with min, and I will continue until I empty the priority queue. I'll get the three values, call it val, which will give me the value, get me the value from this point, from the first position, and the other two positions will give me the indexes. Sorry, this will be one. And now I have to traverse in the four directions, isn't it? So I'll have something of a vector called directions, which will have 0, 1, minus 1, 0, minus 1, 1, 0, and finally minus 1, 0. These will be my directions. I will traverse. I will get the new row and new column like this. This will be one, this will be column. This will be my new row, my new column, and I will first check if it's a valid new row, new column, because it can be out of bounds and we are not allowed to wrap around or anything like that. So I will have a valid check like this. It should be greater than equal to 0. The new row should be less than n, and the new column should be greater than equal to 0, and the new row must be less than, new column must be less than n. Finally, I will check if the matrix value of row and column is greater than, it's greater than, if it's greater than the matrix value of new row, new column. In that case, I'll have something called dp value, which will be initially 1. I'll define it here, which will be initially 1. I will either have the dp value or the dp of new row and new column plus 1, isn't it? Either one, if I don't even need that actually, but in scenarios where we have two values, I need to take the greater value, right? That's why I have this maximum function, right? Finally, I will have the correct dp value, which I'll store it in the, the right place of dp matrix, and I also check the answer for the maximum value. Finally, I will return answer. Let's see if this works, or is there any silly mistake? There is. I have not defined dp. What? Right. I have the dp initialized like this, comma vector of end, and initial value will be 0. Now let's see. Oh, sorry, this will be a semicolon. Let's see, the time complexity will be of n log n. It's going wrong somewhere. Oh, my bad. I'm not copying the priority queue itself, so it should have given me time limit exceed. Something else. Priority queue int m int n, the dp matrix Initialize IFTQ. Oh, my bad. This should be J. Sorry, this should be I, this should be J. Now it should work. Silly mistake. Okay, there's something else. Sorry, I'm looking for greater values around the direction, right? So that's the problem. My bad. This should be the opposite. This works. The time complexity will be O of n log n. Yeah, thanks.